Hello, welcome to my channel. In this video, we are going to solve this interesting problem. So let us first understand what is the problem, okay? So there are two blocks of masses 2 kg and 3 kg, okay? This block is moving in this direction and this one is at rest, okay? Rest at the floor, okay? And there is no friction between the block and the floor, okay? So the floor is frictionless. And this block is moving in this direction, and we have to find out what is the maximum compression of this spring, and spring constant is given K is equal to 120 Newton per meter. Fine. So let us start. First of all, in general, we can write kinetic energy. So I will use in uh, law of conservation of energy, and the kinetic energy of any system is given by the formula that is 1 upon 2 this mass of the whole system and square of velocity of the center of mass, okay, plus this kinetic energy associated with the motion of this block associated with the uh, this block respect to this block, okay. So I'll use uh, reduced mass and this relative velocity square, okay. How did I write this one? So let us understand with a simple analogy. Okay. So let's suppose there is a train and this train is moving. Let's suppose there is a train and this train is moving in this direction. Okay. And there is a two-person. So there are two person and this person is moving in this direction. So you can see here this whole train is moving in a forward direction. So center of mass is also moving in this forward direction. So kinetic energy, this first term is the kinetic energy associated with the center of mass. Okay, because this center of mass is moving in the forward direction, the whole system is moving in the forward direction. That is the kinetic energy. And the kinetic energy associated with the components, that is the energy of this person, the kinetic energy of this person with respect to this person. That is basically the इंटरनल एनर्जी. सो अभी यहाँ पर क्या हो रहा है, यहाँ पर मैं यूज कर रहा हूँ लॉ ऑफ कंजर्वेशन ऑफ एनर्जी. ओके, यहाँ पर आपने देखा कि ये पर्सन जो है इस पर्सन के रिस्पेक्ट में मूव कर रहा है. ओके, सो आई कैन से दैट this part is the internal energy of the system and this part is the energy related to the center of mass because this center of mass is moving in this direction. Okay, so there is no friction, there is no external force. So I can say that this energy cannot be converted into other form of energy. I can only convert this internal energy. मैं इस एनर्जी को कभी कन्वर्ट नहीं कर सकता बिकॉज ये रूल होता है, ये कॉन्सेप्ट होता है कि अगर कोई एक्सटर्नल फोर्स अप्लाई नहीं हो रहा है तो आप सेंटर ऑफ आप वेलोसिटी को आप एनर्जी को चेंज नहीं कर सकते, आप एनर्जी का कन्वर्ट नहीं कर सकते. Okay, you can only convert this internal energy. Okay, so I'll use this internal energy and I can write um, 1 upon 2 mu and this relative velocity square and half that internal energy. And internal energy is given by this formula 1 upon 2 spring constant multiplied with the square of maximum compression. Now I have to find out x, but how can I write this mu value? So let me copy this and I can write here. Okay, so I can write here. Uh, it is given by 1 upon 2. Mu is given by the formula m1, m2, and this m1 plus m2. That is called reduced mass. Okay, and this relative velocity is 1 here. The velocity of this block with respect to this one, it is given by 1 meter per second. So I can write 1 meter per second square and equal to 1 upon 2 into 120 into x, okay, square. So once you solve it, you'll get x is equal to 0.1 meter. So basically x is equal to 10 centimeter. That is answer. I hope you like this problem. Okay.